do is you just divide 150 over 15 and you get 10. Then you just get the log of 10, and that's 1.
Or is it 1?
Yeah, log of 10 is 1.
It's 1.
Then you just multiply that by 60, so then you get 60. So now you just determine the charge. And to determine the charge, you have to look at the concentrations of the ion inside and outside. So because sodium is high outside, it wants to go inside. So the directionality is in the cell. So when you move a positive ion in the cell, it becomes positive. So that's how you get the answer.
If you do it the way that the equation is actually spelled out, you can get it right from the equation, right? It'll give you positive or negative instead of doing the big number by this, because it's always inside over outside, right?
This is a way where you don't have to like memorize the equation.
Yeah,
This is just like,
so much easier.
But I mean,
Yeah,
you
it's
do
so much
the,
like if you do the equation,
Okay, yeah.
yeah.
Okay.
So do you always multiply by 60?
Yeah.
You have to, yeah, you always multiply by 60.
Okay.
But if this was calcium instead, I'd have to divide 60 by 2, yeah.
Does he ask questions based on the charts, or does he give like values in like a clinical scenario?
It'll just be straight up numbers.
Okay.
And keep in mind, he could either give you the concentrations
Right.
like this, or you might have to find out the concentrations. So he'll give you the membrane potential, and then you have to figure out the concentration.
Well, he'd have to give you at least one concentration.
Yeah, he'd have to give you one. So does this make sense about like figuring out the charge?
Yeah, so the chloride would always be a negative number, correct?
It depends on the movement. That's the thing.
Okay, so you always have to look at the movement.
Yeah. So for example, this one, chloride is high outside. This is inside, so it wants to go in the cell. So a negative ion moving in the cell is negative. And if it was reversed,
Be positive.
so yeah, it would be positive. A negative ion moving outside would be positive.
Because he can manipulate inside and outside values to give us for like a theoretical problem. Like he gave us a higher inside value than outside, correct?
Yeah, yeah.
And then it would be positive, I guess. Okay.
Do you understand?
Yeah, I understand it now.
So for the top one, it'll be positive.
Yeah, but the top one is positive. Because yeah, positive
it's
ion.
going into the cell.
Mhm.
Okay. Positive into the cell. Okay.
How about?
We have to memorize these numbers, or that's
No,
good?
he'll give it to you.
Oh, okay.
Okay, so how about for potassium?
I wonder if I do it. It's gonna move out.
It's moving out, so it's gonna become more negative.
Yep, more negative. So yeah. I think that's the most complicated part. But if you understand that, then you should get the question right.
Is it always going to be the bigger number?
Yeah, the bigger number over the smaller number to make it easier.
For chloride, it's just inverse.
Not really. It's the same thing. Yeah, it's the opposite, but just remember it's a negative charge.
Right.
Okay, any questions about this? Okay, and then the math itself would be very simple, because you only have like a minute for each question, so the math is going to be like pretty much like this math, without the calcium part.
So likely not ask as a calcium question.
Oh, you can, but like the values will be a lot easier.
Okay.
So and for calcium, you would instead of multiplying by 60, multiply by 30, right?
Yeah. Okay. Does everyone need me to explain this one, or we got it? You sure?
I missed it. I don't know if you want to
Yeah.
go very quick, like
Yeah.
like quick review.
Mm-hmm. So I'm gonna do chloride. No, that's hard math. I'm just gonna do sodium again. So I'm calculating the net charge of the cell. Okay, so I'll first look at the concentration. So 150 outside, then 15 inside. Okay, so I just divide 150 by 15, and I get 10. Get log of 10, and that's 1. And then 1 times 60 is 60. So now that I figured out the number, I have to figure out the charge. And to figure out the charge, I look at the concentrations inside and outside. So for sodium, because it's higher outside and wants to go inside, and a positive ion moving inside would make it positive.
Mhm.
Okay, and that was the answer. 60.
Thank you.
And then, let's see, how he's gonna ask you to do it, and he could ask you to do it in reverse. So he'd give you like concentration of calcium inside is like 30, and then the membrane potential is like 60. What is the concentration outside? So that's how he could ask you to. Does anyone want to try figuring this out?
I find the fastest way to do those kind of problems is you just plug in the values in the equation,
Mm-hmm.
like the answer values, and whichever answer ends up being 60 is instead of sitting there and trying to figure it out with using E and everything.
Yeah, you're right.
So like if he gives you A through D and you have like, he gives you like 10, 20, 30, 40, 50, just put 10 or the smaller number underneath or the bigger number on top, and then just figure out which one gives you 60. Instead of taking the time to do like the reverse and like E and everything.
Yeah.
Oh.
Yeah,
It'll
that's
save you time.
that's how you solve it. So instead of like trying to figure it out in reverse, you just plug in the numbers in the answers. Yeah. Like I think there might be a practice question, not 100% sure.
How do you know which number to put on top or on the bottom?
You just do the bigger overload number, and then that's really it.
Should it be
Like-
300?
Yeah, 300.
Yeah.
I think. No, it might be
No, because it's you have to multiply by 30 instead of 60 on this
yeah,
one.
might be 6. Not sure.
So it would have to be 100.
100?
Yeah.
Yeah.
No, it'd have to be
Yeah.
3,000 to do that.
Huh?
Wouldn't it? 3,000, because 3,000
Yeah.
divided by 30 is 100. Log of 100 is 10. 10 times 30.
Okay. Then it would be 300. This is 300.
Mhm.
Okay.
Is that all?
That's all I have for this. I'm just answering questions.